Thermochemistry is concerned with how heat affects chemical reactions. So what are the basics? Well, first off, what does delta H mean in thermochemistry? Delta H is the change in enthalpy, or the change in the amount of heat in a system. If delta H is positive, then the process is endothermic, meaning that heat is absorbed by the system. If delta H is negative, then the process is exothermic, meaning heat is released into the surroundings. What is specific heat? Specific heat is the amount of energy in joules required to raise the temperature of 1 gram of a certain substance by 1 degree Celsius. Every substance has its own unique specific heat. Let's take a look at a heating curve. This is a phase change diagram for water. So at its solid state, as heat is added, temperature is increased until you reach the freezing point. Then, as heat is added, temperature does not increase, but rather the heat contributes to melting the ice into water. Once the ice is fully melted to water, the water is now in a completely liquid state. So as more heat is added, the temperature continues to increase. Once you reach water's boiling point, 100 degrees centigrade, then as you add heat, temperature will no longer increase, but rather it will go towards turning the liquid water into a gas. Once the water is fully vaporized, it is a gas, meaning that once you add more heat afterwards, temperature will continue to increase. There's an equation we can use that will determine the amount of heat required to melt or boil something. The equation Q equals m delta H states that Q, or the heat required, is equal to the mass of the substance multiplied the heat of fusion or vaporization, depending on if you are melting or boiling the substance. So let's take a look at a problem. How much heat is required to melt 215 grams of ice at 0 degrees Celsius? Well, since we are at the freezing point and we need to melt the ice to water, we will use the phase change equation. We will use Q equals m delta H to solve for Q, the heat. We can plug in the mass of the ice and the heat of fusion for water in order to solve for Q. And we get 71.81 kilojoules. So we use Q equals m delta H for a phase change. But what about temperature change? Well, we use the formula Q equals mc delta T, also known as Q equals mcat, when the temperature is changing as opposed to when the phase is changing. Q again represents heat, m represents mass, C represents the specific heat of the substance, and delta T represents the change in temperature. So let's take a look at a problem. How much heat is required to heat 7.2 kilograms of water from 12 degrees Celsius to 65 degrees Celsius? So, since this is a temperature change, and we do not pass the melting or boiling point of water, meaning there will be no phase change, we can use the formula Q equals mc delta T. We can plug in our values for mass, make sure to convert to grams, specific heat, which is provided for water, and temperature change by subtracting the initial temperature from the final temperature. And so, about 1600 kilojoules is required to heat 7.2 kilograms of water from 12 degrees Celsius to 65 degrees Celsius. Let's take a look at another problem. Calculate the amount of energy in kilojoules needed to heat 785 grams of liquid water from 11 degrees Celsius to 240 degrees Celsius. So for this process, there are 3 steps. There's first the temperature change from 11 degrees Celsius to 100 degrees Celsius, being the boiling point of water. There's then the phase change of liquid to gaseous once we reach the boiling point. And then there's another temperature change from 100 degrees Celsius to 240 degrees Celsius. For the first temperature change, we will use Q equals mc delta T to solve for the amount of heat required. And so we can plug in our values for mass, specific heat, and change in temperature to solve for Q1, aka the amount of heat required for step 1. And so Q1 is 292,454.89 joules. The reason why I'm not rounding this value is because we will need to use it for a later step. Now, for step 2, we will look at the phase change. So we will use Q equals m delta H to solve for the amount of heat required to go from liquid to gas. So Q2 will be equal to the mass multiplied by the heat of vaporization of water. And we get 1,774,100 joules. Lastly, step 3 is another temperature change, meaning we will use Q equals mc delta T. After plugging in the mass, the specific heat of water in its gaseous phase, and the temperature change, we can solve for Q3. And we get 218,701 joules. In order to solve for the total amount of heat required for this entire process, we must add these three values together. And so we get 2,285 kilojoules. Let's take a look at one last problem. A 123.91 gram sample of an unknown metal is heated to 244 degrees Celsius. This sample is then added to 500 grams of water initially at 10.6 degrees Celsius, and the water heats up to 34.2 degrees Celsius. What is the specific heat of the unknown metal? So while we can't solve for the specific heat directly, since we do not have enough information, we can solve for the amount of heat required to heat the water up to 34.2 degrees Celsius. We can use Q equals mc delta T to do this. And so, after plugging in the mass, specific heat of water, and the temperature change, we can solve for Q, being the amount of heat required to raise the water to 34.2 degrees Celsius. And so, Q equals 49,394.8 joules. Now we can use the first law of thermodynamics, which says that the Q of the system equals the negative Q of the surroundings, where the metal is the system and the water is the surroundings. Therefore, we now have Q for the metal, meaning we can solve for the specific heat using mc delta T. And so, after plugging in Q, M, and delta T, we can now isolate C to solve for it. And so, the specific heat of the unknown metal is 1.90 joules per gram degree Celsius. Thanks for watching. Like and subscribe.